Non-metallic-sheathed cable, commonly known as NMC, is a versatile wiring method used in residential and commercial buildings. However, its application is subject to specific guidelines outlined in the National Electrical Code, or NEC. A common misconception is that NMC can be directly connected to electrical equipment without proper termination. This is often encountered where NMC runs from branch circuits to a service panel located on an exterior wall. The NEC explicitly prohibits using NMC as a direct connection between electrical equipment. Specifically, NEC Section 250.118 dictates approved methods for equipment grounding and specifies which wiring methods are acceptable for grounding and bonding. This section implicitly restricts the direct connection of NMC. The proper method involves terminating the NMC in a junction box or another approved enclosure before making the final connection to the electrical equipment. Let's delve into the reasons behind this requirement and the correct way to perform the installation. Firstly, safety is paramount. Direct connections at NMC increase the risk of electrical shock and fire due to several factors. 1. Loose or improperly terminated connections can lead to arcing and overheating, which can ignite combustible materials. 2. Damage to the NMC sheath can expose live wires, creating a shock hazard. 3. Direct connections lack the mechanical protection that a junction box provides. This can leave the conductors vulnerable to physical damage. Secondly, code compliance ensures safety and standardization in electrical installations. The NEC is a set of guidelines designed to minimize electrical hazards and ensure consistent practices. By prohibiting direct connections of NMC, the NEC aims to prevent unsafe installations that could compromise the integrity of the electrical system. Thirdly, proper installation techniques are crucial for a safe and compliant electrical system. The correct procedure involves several steps. 1. Install a junction box in a suitable location near the electrical panel. 2. Run individual THHN or THWN conductors from the junction box to the panel. These conductors should be sized appropriately for the circuit. 3. Terminate the NMC cables in the junction box using appropriate connectors. 4. Ensure all connections within the junction box are secure and properly tightened. When selecting a junction box, consider the following factors. Firstly, the size of the junction box must be adequate to accommodate all the conductors and connectors without overcrowding. NEC Section 314.16 provides guidelines for calculating the minimum size of junction boxes based on the number and size of conductors. Secondly, the junction box must be suitable for the environment. If the junction box is located in a damp or wet location, it must be rated for such conditions. Thirdly, the junction box must be securely mounted to a stable surface. When running individual conductors from the junction box to the panel, several considerations come into play. Firstly, use THHN or THWN conductors. These conductors are commonly used in conduit and raceway systems and are suitable for this type of installation. Secondly, ensure the conductors are properly sized for the circuit. The ampacity of the conductors must be equal to or greater than the overcurrent protection device protecting the circuit. NEC Table 310.16 provides ampacity ratings for various conductor sizes and installation types. Thirdly, protect the conductors as they enter the panel. Use a bushing or fitting to prevent abrasion of the conductors as they pass through the knockout in the panel. Terminating NMC cables in the junction box requires the use of appropriate connectors. Firstly, use connectors listed for use with NMC cable. These connectors are designed to securely grip the cable and provide strain relief. Secondly, ensure the connectors are properly sized for the cable. Using an undersized connector can damage the cable, while an oversized connector may not provide adequate grip. Thirdly, tighten the connectors securely to ensure a reliable connection. When making connections within the junction box, use appropriate methods and materials. Firstly, use wire connectors listed for use with the conductor sizes and types being joined. Secondly, ensure all connections are clean and free of corrosion. Thirdly, tighten the wire connectors securely to provide a reliable electrical connection. After completing the installation, inspect the work to ensure it meets all applicable codes and standards. Firstly, check all connections to ensure they are secure and properly tightened. Secondly, verify that all conductors are properly supported and protected. Thirdly, confirm that the junction box is securely mounted and that all covers are in place. Ignoring these guidelines can lead to several potential problems. Firstly, electrical shock hazards can arise from exposed live wires or loose connections. Secondly, fire hazards can result from overheating or arcing due to improper connections. Thirdly, code violations can lead to fines, penalties, and the need for costly repairs. In summary, while NMC is a useful wiring method, it must be installed correctly to ensure safety and code compliance. Avoid direct connections of NMC to electrical equipment. Instead, terminate the cable in a junction box and run individual conductors to the equipment. By following these guidelines, you can create a safe and reliable electrical system. It is essential to consult the latest edition of the NEC and local electrical codes for specific requirements and regulations in a specific area. Licensed electricians should always be consulted for electrical work. The NEC is regularly updated, and local jurisdictions may have additional requirements that must be followed. Always prioritize safety when working with electricity. If there is any doubt about the proper procedure, seek the advice of a qualified electrician. Additionally, consider the specific application when selecting wiring methods and materials. Different environments may require different types of wiring and protection. For example, in wet or corrosive environments, use wiring and enclosures that are specifically designed for those conditions. Consider future needs when planning electrical installations. It may be wise to install larger junction boxes or run additional conduits to accommodate future expansion or modifications. Proper planning can save time and money in the long run. Remember to document all electrical work performed. Keep records of wiring diagrams, materials used, and inspections completed. This documentation can be helpful for future maintenance, repairs, or modifications. If unsure about any aspect of electrical work, always consult with a qualified electrician or electrical inspector. Their expertise can ensure that the work is done safely and in compliance with all applicable codes and regulations. Stay updated on the latest changes to the NEC and local electrical codes. Attend training courses, read industry publications, and participate in professional organizations to stay informed about new technologies, techniques, and regulations. By following these best practices, you can contribute to a safer and more reliable electrical system for the home or business. Safe electrical practices protect people and property from harm. They help to ensure the reliable operation of electrical equipment and systems. Proper electrical installations are essential for modern life. Electricity powers homes, businesses, and industries. Electrical systems must be designed, installed, and maintained to operate safely and efficiently. Always prioritize safety, code compliance, and quality workmanship. These are the hallmarks of a professional electrician. Electrical safety is everyone's responsibility. Educate yourself and others about electrical hazards and how to prevent them. By working together, you can create a safer environment for all. Direct connections of NMC can lead to a range of safety issues and code violations. By understanding these issues and adhering to the correct installation practices, a safer and more compliant electrical system can be ensured. Direct connections of NMC can easily be damaged, leading to exposed wires. Junction boxes provide mechanical protection and help prevent this. NMC does not have the same level of protection as conductors run in conduit. Therefore, it should not be used as a direct connection to equipment. Terminating NMC in a junction box also allows for easier troubleshooting and maintenance. The connections are accessible and can be easily inspected. Proper grounding is essential for electrical safety. Direct connections of NMC may not provide an adequate grounding path. Junction boxes can be used to establish a proper grounding connection. The NEC specifies the types of wiring methods that are allowed for equipment grounding. NMC is not one of them. Direct connections of NMC can create a fire hazard if the connections become loose or corroded. Junction boxes help to prevent this by providing a secure and reliable connection. Electrical installations should be performed by qualified professionals. This ensures that the work is done safely and in compliance with all applicable codes and regulations. Permits are often required for electrical work. Check with the local building department to determine if a permit is needed for a specific project. Inspections are performed to ensure that electrical work meets code requirements. Schedule an inspection after completing any electrical work. Proper electrical installations increase the value of a home or business. They also help to ensure the safety and well-being of the occupants. When in doubt, consult with a qualified electrician or electrical inspector. They can provide guidance and advice on electrical safety and code compliance. Electrical safety is a shared responsibility. By working together, everyone can help to create a safer environment for all. The recommendations in this explanation should always be combined with the local, state, and NEC electrical codes for any installation as the final authority.